Morning. Once again, this is the last week, so this is entirely enrichment. Although it's enrichment, I do feel like it is necessary to maybe go over the geometry regions, as the year sort of came to a conclusion rather anticlimactically. I don't know if you agree with that. So,
I do.
I do want the year to close off with some sense of closure, which is why I'm doing this. So let's take a look. I want to share my tablet with you guys. And this is just to give you a sense of how far in the curriculum we've gone. And if you ever do decide to take the Regents for whatever reason, make your transcript look, if you want to prove to yourself that you actually know the material, okay? It's always good to just take a look at the standardized exam and see where you're at, because only
But
you can tell where
uh,
you are. Yeah, go ahead.
is it smart for me to take the regents in January considering the grade I got in your class?
Is it smart to take the Regents in January? It would be smart if you do prep work before then, right? So
Because
I think you're perfectly capable of doing really really good work. But with that said, you still need to do a lot of preparation.
like I got 98, and that what if I didn't do as well when I took the actual test?
You know, with some amount of time between the course and the actual exam passing by, right? You're going to get rusty, and that's just the natural, course of things. Speaking for myself, I've graduated from college like years now, right? Just about 20 years. And if you ask me, whether I remember, such and such course on thermodynamics and, um, those really, really abstract classes, I can tell you I remember nothing. I gave it all back to my professors. Does it mean that I'm not capable of doing well on those on the engineering exam? No, not really. But you do need to prepare, and you do need to look over things. So in January, if you do decide to take it, I think you would still need to prepare. You would still need to go out and you know, purchase a Regents book and do some of that legwork when you're. Okay, so let's take a look at this guy right here. So this is the example right here, and this looks really, really, really similar to one of the questions from the beginning of the year. Yeah, in the first semester, the fall semester of this year, you were in Mr. Rubel's class, right?
Yeah.
So this was something that was covered in his class. We did it in my class. So it says here on the set of axes below, triangle ABC is graphed. Triangle A prime B prime C prime and A double prime B double prime C double prime are the images of A, B, C after a sequence of rigid motions. Okay, very well. And what we need to do here is identify with sequence of rigid motions uh, that maps ABC onto A prime B prime C prime, and then mapping to from A prime B prime C prime onto A double prime B double prime C double prime. So how would you characterize that? What's happening going from ABC, right? Let me make this marker a little thicker. Going from ABC and then to A prime, and then finally to the double primes there. What would be the best description of that transformation, of that
Num-
motion?
Number 4.
Yeah, it's a reflection followed by a rotation. That's right. If they wanted to be really tricky, right, they would have been a little more specific as to, like, what's the rule for the reflection or what's the rule for the rotation, but they didn't go down that route. Okay, let's take a look at the next one.
Oh, I mean, it
Yeah,
would have been that. It would have been 90 degree.
that's
It would
right.
have been worse.
it would have been 90 degrees. And anytime that you're rotating anything over a coordinate grid, it will be of multiples of 90. This would be positive 90 or negative 90.
It should be positive.
That's right. So, and again, the way to remember this is the way that I introduced it in my class back in the fall semester, right? The sun rises in the east and sets in the west, right? So this is a positive rotation, this orientation. And that's pretty much been the benchmark that we've been using to denote what is a positive rotation. When we talk about like clockwise and counterclockwise, right? A clockwise motion goes like that. That's actually negative rotation.
Uh,
Okay.
and yeah, I always thought of it just the opposite of clockwise.
Right. Okay, number 2. The table below shows a population and land area in square miles of 4 counties in New York State at the turn of the century. So we have these information of the 4 counties. We have the population and the landmass, the area. Which county had the greatest population density? Now, this is something that we didn't talk about in geometry, although this is a topic that was covered in your science classes, especially over the beginning of the year. When we talk about density, it's some quantity, right, over another quantity, right?
I
So in
don't have
this
a
case,
calculator on me, but
you
I'm
can,
gonna go with
mhm.
Niagara.
uh,
It just looks right.
it looks about right. Yeah. Well, in order for us to tell, maybe can you care to explain?
Well, it has the lowest land area out of any of these, and it has the second highest um population, and I think that Duchess's area is like was it like 300 more,
Yeah,
and the populations are only 60,000 more, and I think that's enough for Niagara to overcome to be the densest.
I would agree with that, Emmett. However, if one is uncertain, right, you should certainly take these two values and punch it in a calculator and see which one has a higher number. Okay, good job. Number 3, if a rectangle is continuously rotated around one of its sides, what is the three-dimensional figure formed? So is it going to be a rectangular prism? Is it going to be a cylinder, a sphere, or a cone? This is one of the topics that we have not talked about this year directly. And this, if we were in regular school, this topic on three-dimensional shapes would be at most like a week. And just because a lot of it is based on just intuition and a little bit of logic. Oh, what do you think would happen here?
Huh.
If you take a rectangle and rotate it on its axis, on one of the sides, rather, what kind of shape are you going to form?
I want to go with one. Just,
Rectangular prism?
yeah, probably wrong.
It's not it. So a rectangular prism, just so that so that we have a understanding of what each of these things are. So a rectangular prism looks like this.
All right.
This is a rectangular prism. Okay. A cylinder would look like this.
Yeah, I mean,
And then
maybe cone.
a sphere is a ball, right? Okay. And cone looks like that. So what would happen is, let's say if I take this rectangle, which looks like this, and I begin to rotate it around an axis. right? So it's going to look like that. And then like this. And then like this.
Cylinder.
Yeah, it's going to look like a cylinder.
It's like worded a little bit confusing. It's like hard to picture.
Yeah, I do agree with that. So it's going to be a cylinder. Okay.
I mean, now I can imagine like a door swinging around on its hinges in pictures.
That's right. That's right. That's exactly the situation. Okay. Transformation, um, which transformation carries the parallelogram below onto itself? So would it be a reflection over y equals x, a reflection over y equals negative x, a rotation of 90 degrees counterclockwise about the origin, rotation 180 degrees counterclockwise about the origin?
Uh, 4.
It would definitely be four. It would definitely be four. So anytime you pull um, a 180, right? Uh, Basically, if you look at this parallelogram, okay, it's centered at the origin here. You can tell, by looking at the coordinates of the four vertices here. And if I take this point over here and rotate it 180 degrees, it would land over here. If you take this endpoint over here and rotate it 180 degrees, it will land there, right? And so forth. So yes, absolutely. The others wouldn't make any sense. We can talk about reflection about over y equals x, but if we if we reflect something over the line y equals x, if we recall y equals x like this,
Right. Yeah, it wouldn't work.
it wouldn't work. So this point would actually end up over here. This point would end up over here, and then this point would end up like right there, and then this point would end up like right there, right? So it will look something like that. Doesn't make any sense. Okay. All right. After dilation, centered at the origin, the image of CD is C prime D prime. If the coordinates of the endpoints of these segments are C, 6 comma negative 4, so on and so forth, the scale factor of the dilation is. So now we're getting into one of the last things that we did before remote learning began, right? So we're going for a dilation going from CD to C prime D prime.
Right.
Maybe think about for a moment here what you think you would do to find that out. What would be the strategy?
Uh,
Right?
uh,
Yeah. Mm-hmm.
yeah, you could just set a proportion
Set a proportion. Okay.
between like C and C prime, but I have the answer. I think it's 1.
It's one.
No, I know it's 1. I know.
You know it's one. All right. Care to elaborate?
Yeah, it's says I just use C, 6 negative 4 and then 9 negative 6. You multiply by like 1.5, which is 3 over 2,
Yeah.
and then you
Yeah.
get 9, and you could
Yeah.
also get negative 6.
That's right. So certainly, if you have some number sense, right, you can tell just by how C changes to C prime. And if you recall, when we're performing a dilation, we're multiplying every coordinate by, some scale factor. Okay. So any of these other options here wouldn't make more sense.
Right.
Okay. All right. The line negative 3x plus 4y is equal to 8 is transformed by a dilation centered at the origin. Which linear equation could represent its image? This one's a little tricky, and I actually recommend if you have paper and pencil to try and sketch this out.
It's two.
I think it's 2.
Yeah.
Okay. Why is that?
Wait. Oh, an image. Well, if it's transformed, oh, that's gonna be 3. Yeah,
How do you know?
because well, 2 would just be the equation without a dilation at all.
Uh-huh.
So at least there's some dilation with 3. Everything's negative. What?
So
Uh,
this is a line, right? And it's the dilation of some other line.
uh,
I have negative 3x plus 4y is equal to 8 right now. Just by inspection right here, okay? If I were to figure out what the slope of this line was, okay, what would you do? The slope of this line here.
it's 3/4.
It is 3/4. That's right. And what would be the y-intercept?
It
Would be 8. I'm just going to redraw this here a little bit. So
wait,
something like this. So I have
no,
8, and then
no,
the
wait,
slope would
wait,
be,
no, it'd be 2.
I'm sorry, it would be 2. You're right. It would be 3/4. So this is 0, comma 2, and then would have a slope of line 3/4, right? So this line is the image, okay? If this was a dilation, okay, then the original line could look something like this, right? It didn't say it's a dilation of how much in this problem. Did you recognize that?
Yeah.
Okay, so it could be that dotted line that I drew. It could also be this dotted line that I'm drawing above it. It could be either one of them. It could be a dilation where we're increasing in size, and then it could be a dilation where we're dropping in size. Okay, but one thing's for sure, what has to be the same between all 3 of these lines that I drew?
A 3/4 slope.
It has to have a slope of 3/4, which was your original choice, right? So
Huh.
what's the point of this? The point is, or the question here is really testing your understanding that when you're dilating a line, okay, what will be the same between the image and the original? It has to be the slope.
Right.
Okay. All right. In the diagram below, AC and BD intersect at F. I'm sorry, intersect at E. Okay. Which information is always sufficient to prove triangle ABE congruent to triangle CDE?
That I would say number 1.
Number 1, so
Yeah.
AB parallel to CD.
Mm-hmm.
So if AB is parallel to CD and AC and BD are therefore going to be transversals, right? So the
Yeah.
conclusion that we can draw from that is, okay, we can certainly say that these angles are going to be congruent
And
because
the other,
alternate interior, right? And we can
and then
say,
same with D and B,
and then say the same thing. Say that again.
and then same with both angles off of AE, B, and DEC.
That's right, and because of vertical angles. So we have all the angles, all the corresponding angles are the same. Is that going to be enough to prove that these two triangles are going to be congruent?
No.
No. So we need at least a side, right? We need to have at least one side in order to show triangles congruent.
Huh. Oh, I found something.
It's okay. Take your time.
No, I found something. I think it's 2.
I think it's 2.
Yeah,
Okay.
because
AB. Go ahead.
the angles on E are givens no matter what. Like you know that the AEB and DC are congruent all the time, and then if AB is congruent to CD and BE is congruent to DE, then you can have SSA. I mean, no, that's not a thing.
Okay. Do you want to rescind that?
Yeah, well, I mean, if two are congruent, doesn't that mean the third is too?
Mm. You can't say you can't. That is not sufficient. You cannot have two corresponding sides with one angle not being the included angle. Um, prove two triangles to be
No.
congruent.
Oh, it's 4.
It is 4. Yeah. ED and AC bisect each other, right? So if that's the case, then that means these two are the same, right? And
Right.
then these two are the same. And these angles over here being vertical angles are the same.
And that's
What?
SSS.
SAS, that's right. So it would have to be 4. Okay. All right. The expression sine 57 is equal to, this is something that we had learned over remote learning. Take a moment here, see if we can figure that out.
2.
Question 2,
Uh-huh.
it indeed is. And the identity was, right, the angles on the inside, these two angles had to be complementary. Okay? All right.
Yeah.
All right. What is the volume of a hemisphere that has a diameter of 12.6 centimeters to the nearest tenth of a cubic centimeter? All right. So in order for you to do this, okay, um, because this is something that we have not done in the remote learning. So the volume of a sphere, and the
Wait, is it
reason
like 4/3 something?
it's 4/3 pi r cubed, and then the
Right.
surface area of a sphere is equal to 4 pi r squared. So, and again, I keep on saying that if regular school were to happen, like this unit on 3D geometry would be at most a week. Well, that's because it's just a lot of formulas that you need to be introduced to, which is what this is asking for. Okay. So
Right.
how would you go about this?
Um,
So a hemisphere, right?
it's
What
half of the.
yeah, it's just half of a sphere. So what is the volume of a hemisphere? If you're told that the diameter is equal to 12.6, what would you have to do then?
So I would. Well, so it's 6.3. That's the
Yeah.
radius. So I just find the thing and then divide it by 2.
That's it.
So, I mean, I guess I have a computer calculator. I don't have my graphing calculator, but we can try this.
So just a ballpark, right? Well, half of 4 is how much?
Well, it's 2.
It's 2, right? That's going to be 2. And again, I'm just ballparking, right? So what about 3 and pi? Are they going to be relatively close together? Like, are these two numbers really close?
Uh, yeah,
They
they're
are,
very.
right? So 3 and 3.14, they're really, really close, right? So this is like approximately 2 times 6.3 cubed, right? And again, I'm just going to ballpark, right? Is it going to be, and this is going to be an under approximation, right? It's going to be approximately 2 times 6 to the third, then, isn't that right?
Yeah.
Well, if that's the case, I have 6 cubed. What exactly is 6 cubed? That's 36 times 6, right?
So 180 plus 36, 216.
216. That's right. 216 times 2 is 432. All the other numbers just like ridiculous. Can you say?
Right.
There's only one reasonable answer, and what would that be?
1.
Yeah, option 1. So this guy right here, right, 16 into the system is equal to 432. And the reason why we end up with such a small number compared to the actual numbers because we did a bunch of rounding. But you know the answer choice is there. The other 3 options are ridiculous. So, all right, let's take a look at the next one. Okay, in the diagram below, triangle ABC, D is a point on BA, E is a point on BC, and DE is strong. Lovely. Okay, and then BD is equal to 5, DA is equal to 12, BE is equal to 7, and you're asked to find what is the length of BC so that AC and DE are going to be parallel. So looking for this overall thing so that these 2 lines are parallel. I'll give you a moment to think about this. This is one of the last things that we did before remote learning too.
I think it's 1.
Option 1. All right.
Yeah.
Why do you say that?
Because it's a ratio.
It's a ratio. That's
It's a
right.
proportion.
That's right. So how did you set it up?
I set it up that it's 5 to 17 equals 7 to over x.
That's right. We end up with 5x is equal to 7 times 17. X is equal to 7 times 17,
Which is like 119.
which is like 119 over 5. That's right.
No, it was 119, I think. Yeah, it was.
That's right. That's right.
And then you get 23 point.
That's right. Okay.
Yeah.
Good job there. Okay, moving on. Quadrilateral must be a parallelogram if this is semester 1.
I think it's 3.
One pair of sides is both parallel and congruent. You are absolutely right. This was one of the conditions for showing a quadrilateral is in fact a parallelogram, right? So there were, I think, 4. I forget how many there were. So one was opposite sides are congruent, right? Opposite sides are parallel. Opposite angles are what?
Are congruent.
Right. And then we have diagonals.
Bisect, right?
That's right. Each other. And the 5th one was one pair, parallel and congruent.
That makes sense.
Yep. Good job. Moving on. Question 13. In the diagram below, circle O, which JT and ER intersect at M. If EM is equal to 8 and RM is equal to 15, the length of JM and TM could be, this was one of the things that we did not do. So in the over remote learning, we talked a whole lot about the angles formed between chords, secants, and tangents, right? What we did not talk about in the circle unit was the lengths of chords, okay? So there was a theorem, okay? The theorem is this, that if you have 2 chords intersecting in a circle, it can be shown that the segments, let's call the segment here A, the segment B, and the segment C, and the segment D. It can be shown that segments A and B, which is a part of that one chord, the product of those partitions will equal to the product of the partitions of the second chord. So with this formula in mind, okay, see if you can solve this.
Huh. All right. This is just multiplying. So, not number 1. I didn't even need to multiply for that.
That's right.
Not number 2. All right, so 3 is the answer.
3 is the answer.
Yeah.
I think you are right. Care to elaborate?
If you multiply up 8 and 15 and 16 and 7.5, they both equal 120. And now I just realized I didn't even need to do math because they're proportionate.
That's right. That's
I
right.
didn't know if they were going to be, and then I just realized, oh, they are.
Yep. So 16 times 7.5 is in fact also equal to 20. All right. Triangle Joe and Sam were drawn such that angle E and angle M are congruent. EJ is congruent to MS. And which mapping would not always lead to the 2 triangles being congruent? So E is congruent to M. Right? So these 2 are the same. And EJ and MS are the same. So actually, E, E is congruent to M, and EJ is congruent to MS. Which of these would not lead to the two triangles being congruent?
Oh. Hmm. I don't know.
I'll give you a hint. You want so remember the ways in here where we're talking about not, right? So let's talk about the things that are going to prove, right? To prove the two triangles congruent. We can have SSS. We can have SAS. What else can we have?
It can have uh ASA if
But and then what's another one?
uh
There's one more.
AAS.
That's it. AAS. These are the four that prove triangles congruent, right? We can also talk about like specific kinds of triangles, like right triangles
Right.
involving hypotenuse leg, but we don't have a right triangle here, or we don't know that we have a right triangle here. So, in other words, okay, of the four options here, which ones will not produce any of these?
Number 3. No, number 4.
Number four, you got it. Okay. If it was number three, then what would that which theorem um, would prove the two triangles congruent if it was option three?
Option 3 would be um that would be SAS.
Good. That's it. You got it. Okay. And this guy, 15. Triangle ABC shown below. Angle ACB is a right angle. Angle E is a point E is a point on AC, and ED is drawn perpendicularly to hypotenuse AB. Okay. We're looking if AB is equal to 9, so this entire length is 9. BC is equal to 6. DE is equal to 4. What is the length of AE? I'll give you a moment to think about this.
Two. It's the not like the length is two, but the answer is two.
I believe you are right. Care to elaborate?
Well, these are um are they similar triangles?
Good. So the
So
large, go ahead.
right, so AE is the hypotenuse, so it's similar to AB. And
That's
DE
right.
is similar to BC. So we know that they share like 4 times 3 over 2 equals 6. And then but I mean, sorry, we have to multiply by 2/3 to get to a smaller one. So then if you multiply 9 by 2/3, you get 6.
That's right. Good job. Right. You can also try to set this up, right? You know that 4 corresponds with 6, and AE, let's call that X or something, right?
Right.
Must correspond with 9.
Right.
That's another way of solving it. Okay. And I think maybe we'll call this one the last one for today, and then we can pick it up tomorrow.
Yeah, sounds good.
Yep. Number
Let's hope,
16.
let's
What was
hope
that?
someone else joins let's hope someone else joins tomorrow. It's good practice.
It is good practice. It's great practice. All right, number 16. Which equation represents the line parallel to the line whose equation is negative 2x plus 3y is equal to negative 4 and passes through the point 1 comma 3? Give you a moment to think about this.
Uh, 2, 3. Ah, ah, ah. Makes a lot more sense. 2.
Option 2. Care to elaborate?
Uh, it's in point slope form. So it's y plus y1 equals m plus x1 or x minus x. Sorry, and
Yeah.
then right, and then the slope is supposed to be 2/3.
Yep.
So then that eliminated 1 and 3 right off the bat,
Yep.
and then you're not supposed to add them even though they're positive points. You're supposed to subtract them because of the equation. And then you got y minus 3 equals 2/3 x minus 1.
That's right. So by isolating y to this equation, we end up with slope is equal to 2/3.
Right.
Awesome. All right, I'm gonna hit stop recording, and then we're gonna pick this up